All right, perfect. So we'll go ahead and get started and we'll go a little bit through the background of this. So Chill Skills, it's our monthly webinar, our monthly tech talk. And this month we are focusing on how to select a solenoid valve. All right, so some administrative things first. If you do have a question, if you're on Zoom, there is a Q&A section in your taskbar. Feel free to leave questions there. I have a couple of colleagues here on the line that can help answer questions if I don't get to them. Jim Eckelkamp from our applications engineering team is free to answer your questions. All right, as I said, we do have monthly webinars. In November, we're going to start to focus on supermarket refrigeration, and we're going to focus on the high side components. So we'll start with heat reclaim and split condenser valves. Then in December, we'll get into head pressure control. That's perfect for the wintertime. All right, so if you're joining via Zoom, if you do not have your sound via computer, there is a dial-in that was included in the invite. Please mute your microphones. They should already be muted anyway. Type your questions again in the Q&A section. And just so you are aware, we are recording this webinar. Okay, first and foremost, I want to introduce myself. My name is Henry Papa. I am the Sporlan sales engineer based out of Florida, but I cover a couple of states in the Southeast. If you have any follow-up questions, concerns, any topics you'd like to cover, any follow-up questions again, feel free to reach out to me. My name is Henry Papa, and my email address is henry.papa@parker.com. All right, so to select solenoid valves, in this webinar today, what we're going to talk about is essentially this, is to obtain reliable performance with solenoid stop valves on either refrigeration or air conditioning systems. Demands must carefully be considered for application requirements during the selection process. Okay, and this training module will provide details on how to properly select Sporlan solenoid valves to ensure dependable operation. All right, so you'll be familiarized with the two basic types of solenoid valves based on valve operation. We covered that in last month's webinar. We're going to touch on it again today. Okay. You'll also learn why proper sizing to maintain sufficient pressure drop across the main port of a pilot-operated solenoid valve is crucial for consistent performance. And then you'll also be taught how various available features are identified with our nomenclature to designate Sporlan solenoid valves. Okay, so Sporlan offers a wide variety of solenoid valve sizes, styles, and they may be employed in either refrigeration or air conditioning systems. And what these are used for is to electrically control refrigerant flow. Now, solenoid valves are electrically operated solenoid stop valves, and the plunger inside of these valves is pulled up by an electromagnetic force. So as you apply current through the coils, that creates a magnetic field, which will lift or lower a stem and plunger. Okay, so these valves will either be fully open or fully closed. Solenoid valves do not modulate flow, all right? So just think of it as an electrically operated ball valve, essentially. Now, they're going to be classified according to the stem and plunger action. And the two main types that we have are direct acting and pilot operated valves. Okay, in a normally closed, meaning it's closed when you don't have power, direct acting solenoid valve, when you energize the coil to raise the plunger, it's going to directly open the main port. So direct acting means by energizing the coil, it will directly open the main port of the valve, allowing full flow. Now, this type of construction is going to be limited to smaller ported valves, meaning the internal port of the valve. So usually less than 1/8 of an inch. Now, our solenoid valves with this design are going to be the E2, A3, E3, and XSP. Again, those are our smaller sized solenoid valves. So the flow capacity for those valves, since they are smaller, will be limited for smaller applications or for use on applications where there's low pressure differential across the valve itself. Okay, and while these valves can typically operate to low pressure differentials, a minimum of 1 psi pressure drop is generally recommended. And we're going to talk about that too. It's very important for our pilot operated valves. Now, what you should know is that all solenoid valves have a maximum operating pressure differential rating beyond which the magnetic force generated by energizing the coil is insufficient to open the port. Meaning, if you have too large of a pressure drop across the valve, you won't have enough magnetic force to actually open the valve. Okay, so we talked about direct acting valve. Now let's talk about our pilot operated valves. Okay, in a normally closed, again, without any power, this valve will be closed, pilot operated valve. When the coil is energized, it will lift the stem and plunger assembly, which is going to open a pilot port. Now, when we open the pilot port, that's going to release pressure that's on top of the disc, and it'll allow the disc to move upward, which will open the main valve of the port, then allowing for full flow of the system. So again, these are going to be valves that are larger than our E2, A3, E3, XSP. So anything with a port size over 1/8 of an inch will be pilot operated. And so let's talk about how these operate. Okay, so in our pilot operated valves, the disc or piston or diaphragm will contain a pilot port and an equalizer hole. When the coil is de-energized, the equalizer hole that you'll see highlighted here with this arrow will allow the inlet pressure to the valve to bleed into the chamber, which is going to be above the disc, which holds it closed. Now, when we energize the coil, this will pull up the stem and plunger assembly. The stem and plunger assembly will be held to the top of the enclosing tube in the center of the magnetic field of the coil. Now that fluid pressure that's above the disc is allowed to vent into the main body of the valve. Now, making sure the valves are sized correctly, that's going to allow the pressure above the disc to flow through the pilot hole quicker than the equalizer hole. So then that inlet pressure will act on the bottom of the disc, which allows it to lift open, and that allows your full flow through the main port of the valve. You see that in figure C. Now, once the main port is open, the disc will be held off of that seat by the pressure difference across the port as full flow is achieved. Okay, and that's the importance of that pressure drop across the valve. All right, so now when we want to close the valve, when you cut power to your coil, let's see this here in figure D, the stem and plunger will fall down either by gravity or the kickoff spring that you see on the top of the stem and plunger. That's going to close the pilot hole. Now the pressure above the disc is no longer vented downstream, and the equalizer hole will allow pressure to build up back on top of the disc, closing the disc, pushing it down to sit on the seat. Okay, now we've been talking about normally closed valves, and now we'll touch on normally open valves. So in a normally open valve, meaning that it's normally open when you have no electricity to the coil, the stem and plunger is actually pulled down, which closes the pilot port versus being pulled up in a normally closed valve. Now, as you close that pilot port, again, the same way as the normally closed valves, your inlet pressure will be allowed to flow through the equalizer, which will sit on top of the disc, closing the valve. And as long as you have electricity current to the coil, this will keep the valve closed. Okay, so this is something that I've always wanted to talk about because I see this a lot in the field, which is the tendency for the industry to select solenoid valves based on line size. So if a liquid line solenoid valve is to be selected for a system that has a 5/8 OD line size, the tendency would be for a tech to go into a wholesale branch and ask for a 5/8 liquid line solenoid valve. Okay. However, now due to the pressure drop required for the operation, as we just discussed, it could be risky and not recommended. And we'll talk about why here. Okay, so as an example, we're looking at a 5/8 OD liquid line size. But with our product line, we have 4 different valve series that have 5/8 liquid line size. And they range from 6 tons all the way up to almost 23 tons. So let's say this is a 15-ton 410A system. If you came in and just asked for a 5/8 by 5/8 solenoid valve, you could have a valve that would be drastically undersized, so you may be starving your system, or it could be drastically oversized. And again, without proper pressure drop across the solenoid valve, your valve will not be able to function. It will stay open if it's a normally closed valve, or stay closed if it's a normally open valve. Okay, so in this example, for our 410A 15-ton system, the E14 series would be the right size that we would need. Okay, and if we chose the E8 or the E10, we would be starving our system. With the E19, we wouldn't have enough pressure drop to correctly operate the solenoid valve. And that way, to avoid difficulty, the easiest way to remember this is make sure you're sizing your valves adequately and to the actual capacity of your system, not just the line size. Okay. And so what we had found in that previous example, the E14 would work correctly. And we can also see that we do have the option for either 5/8 or 7/8. Okay, and you can always remember this, that valves can always be adapted to the selected line size, but you can't change the actual flow capacity of the solenoid valve. Okay, there's a ton of different bushing options, reducing options, couplings. So downsizing or upsizing line size will not affect operation as long as you have the correct port size of your solenoid valve. All right, and now one of the other options we have, which is great, is a manual lift stem. You'll see this called out by the M in front of this part number, where it says type ME14S250. The M means it has a manual lift stem, which is a stem internal to the valve. So without power to the coil itself, you can drive in that stem, which will push the seat off of the disc off of the seat to allow for full flow. This is great, especially on new installs without power to the valves. You can open up your solenoid valve, which can allow to pull a quick vacuum. All right, and if you do not have a manual lift stem and still want to operate a solenoid valve without having power, we do have solenoid service magnets. So you would take your coil off and slip this magnet on top of the enclosing tube, which will pull the plunger up or down depending on what type of solenoid valve. And this will allow the solenoid valve to be completely open without the risk of burning out a coil, or again, if you do not have power. And these do work on all Sporlan solenoid valves. Okay, so this here is a typical solenoid valve part number, and I'm just going to walk through these step by step. So again, the M at the beginning of this part number, it'll call out that it has a manual lift stem. The E will call out extended ends off of the body itself. The 6 will be the internal port size, which is in 30/2 of an inch. So this is 6/32 or 3/16 of an inch port size. The S will mean there is sweat connections. Now this one here after the S is very important. That is going to call out what coil size to use. So this would take an MKC1 coil. Then the number after that will be our connection sizes, which is in 1/8 of an inch. So this is a 3/8 by 3/8 ODF solenoid valve. All right, so once we've selected a solenoid valve model, now we need to choose the proper coil type. Okay, and that's going to be based on electrical characteristics. All right, now for our normally closed type solenoid valves, we have our MKC1 and MKC2 coils. That's going to be the different sizes. And again, in that part number we just looked at, after the S in the part number, you'll see a number either 1 or 2, and that will indicate if it takes an MKC1 or MKC2 coil. Now, for normally open solenoid valves, these do have different types of coils, okay, and these are going to be designated with an O before the MKC. So for a normally open valve, we'll have an O MKC1 or an O MKC2. Again, look after the S in the part number. If it has a 1, that'll be a size 1 coil. If it has a 2, a size 2. Okay, and for those that do work with the rapid cycle solenoid valves, those also take OMKC coils because of the construction. Okay, now some of the most popular options will be 120, 50 by 60 hertz, also 24 volts, and as well 208. But that about wraps up what we have for solenoid valves. Does anyone have any questions on Facebook or Zoom? Okay, a couple questions here in the chat. Let's see here. I'll start with the chat here. So it says, when looking at existing valves, does it always show the model number? Hopefully it does. So our part numbers are stamped on the top of the coil. Double check something here. Jim, is the part number also stamped on the body for our solenoid valves? I know we typically do that for our expansion valves, but I just want to double check that it would be for the solenoid valves as well. Good amount of questions coming in. Well, while Jim gets to that, let me answer this one. Linda asks, if capacity does not match exactly, is it better to go a little up or a little down in capacity? So again, Linda, you want to make sure you can handle the actual capacity itself. The limitation for solenoid valves is it has to maintain at least 1 psi of pressure drop. Anything sized larger than that with a lower pressure drop will not function correctly. And so that kind of answers Alan's question as well. What are the symptoms of an undersized valve? And I'm guessing you mean an undersized and oversized. So an undersized valve, you would be starving your system. So you'd have either a really low suction pressure and high superheat if it is a liquid line solenoid valve. If it's oversized, if you try to close your solenoid valve, it will not close. Okay, I'll try to get to some of these questions here too. Brian asks, what do you have for biflow operations, specifically asking for heat pump applications? So we do have solenoid valves with internal checks. I believe those are limited to the E6 size. And if you do need to go larger than that, we would recommend having an external check. Product selection software. Okay, good question. If you were talking about the downloadable selection software, we just updated. We have our new virtual engineering software, and that can be found on sporlan.com or sporlanonline.com. And if you haven't checked that out, it's a great tool, and it does have the current solenoid valves. And Steve, no, not all solenoid valves will be listed as HP. So for high pressure, they do have, our high pressure valves have a different construction plunger. So they are not all the same. But that does bring up a good point. For high pressure systems like 410A, you will need to use a high pressure valve. And especially now with CO2 coming out, very popular would be our high pressure liquid line solenoid valves. Julio asks, from the presentation, it looked like the pilot operated valves would have a greater flow. Is that true? And that is true. Reason being is because on our larger solenoid valves, you will have to use a pilot operated because of the large pressure differentials, because of the high pressure. And if you wanted to do direct acting solenoid valve for a larger application, you would need a very big coil. And so that's typically why they have a larger flow, is because they're larger valves. And so, Steve, it sounds like you're asking what type of solenoid valve would you use on a refrigeration system? And so that's going to depend on what refrigerant you use. But typically, if it's medium temp, low temp, you'll just use our standard solenoid valves. You won't need to use a high pressure valve. Okay, so Fairs is asking, I've seen solenoid valves installed outdoors, some of them inside the condensing unit and some outside the condensing unit. Is that exactable? And so I would say ideally you would want this in some type of covered enclosure, even if it's in your condensing unit, if it's close to your evaporator, just to protect it from the elements. And so Alan asks if you size multi-evap systems the same. It depends if the evaps are the same size. If they're split, in half, then you can split your solenoid valves in half. The capacity would be half. But if you're using one single solenoid valve, you would have to size for the full capacity of the system. Oh, so this is a good question, and I think it answers two here. So Darshan asks, will a solenoid valve work if they're installed in the wrong direction, i.e. swapped? So pilot-operated solenoid valves do have a correct orientation, right? Let me hold that thought. Let me get back to a picture of a pilot-operated solenoid valve. I guess this will do. So if you ran this solenoid valve in reverse, right? So instead of coming in through the inlet, you came in through the outlet. There's no way for pressure to get to the top of the solenoid valve, right? Because there's no equalizer through here. So as you operate it, let's think about what happens here. If you pull open the stem and plunger, you have pressure going in through the pilot hole, and it's only going to sit above the solenoid valve, so it would stay closed. It wouldn't function correctly. However, let me just answer that part too. With a direct operated solenoid valve, it would function fine in either direction because your stem and plunger is opening the full actual port of the valve. All right, well, while we get to this last question, thank you again for all your time today. Thanks for paying attention. This will be on Facebook and YouTube. And again, if you have any questions, feel free to reach out to me, henry.papa@parker.com. Fairs, yes, you can split solenoid valves in that sense. Yeah, you want to make sure they would be equal though. So for a 10-ton system, 2 5-ton valves would handle it fine. Okay. All right, so if anyone has any follow-up questions, feel free to drop them on our Facebook page. Just look up Parker Sporlan and we will get to them. So again, thank you for your time, and we'll catch you on the next one.